as divisibility questions get more complicated, you are going to have to start thinking more in terms of variables than in terms of the numbers that they give you. So when they give you a number, it is usually easy to determine all the properties of that number, especially if you know your divisibility rules. Now, when they give you a variable, though, there are sort of two components, two things to think about. There's what could be true, because that variable is multiple, it represents multiple possibilities. And so there's what could be true about that number, and then what must necessarily be true about that number. And people get those two things confused. Just because something could be true about some variable x, just because x could be a multiple of 3 does not mean it necessarily has to be a multiple of 3. And so you need to make sure that you are answering the question, or you're thinking about the question properly. If it's asking what could be true, then you need to think about all possibilities. If it's thinking about what necessarily must be true, then you got to determine what is always going to be the case. So for this question, it says, is x divisible by 30? So how can we think about this? There are multiple ways we can think about this. Is 30 a factor of x? Is x a multiple of 30? Is x over 30 equal to an integer? And I sort of like this way of writing it because it gives you an equation, and you can even then rearrange your equation. In this case, we are rephrasing our question, which is important to remember. So we can write this as, is x, just multiply each side by 30, is x equal to 30 times an integer? Then we can even want to further break up 30. So if it's going to be divisible by 30, it's going to be divisible by 5 and 6. It's going to be divisible by 10 and 3. Or we can just fully break it up and say, is x equal to what is 30? 2 times 3 times 5. 2 times 3 times 5 times an integer. Now this integer can be anything. It can be 1, 2, 3, 4, 5, 6, 7. So we don't necessarily know what this integer is contributing to x. So what we're asking is, at a minimum, does x contain a 2, a 3, and a 5? Do we know that necessarily x must contain a 2, a 3, and a 5 at a minimum? So for all of these questions, it looks like they're telling us something about 6x and 5x, but I'm always thinking in the back of my head, my goal is, well, what is this telling me about x? So statement 1 says 6x is divisible by 30. So what does that mean? So that means 6x over 30 is equal to an integer. So what is that telling me about x? So 6x over 30 is the same as x over 5. We simplify this. So x is equal to 5 times an integer, which is really just saying x is a multiple of 5, which is what this statement is telling us. So just because something is a multiple of 5 doesn't necessarily mean it's a multiple of 30. So we have our 5 here, but it doesn't tell us anything if we have our 3 and our 2. We could have our 3 and our 2, and if we would have those would come from this integer here, but we don't know that we have it. Statement 2 says 5x is divisible by 30. So if we do the same thing, this is saying 5x over 30 is equal to an integer. 5x over 30, that is the same as x over 6. So x over 6 is an integer. Means x is equal to 6 times an integer. Means just x is a multiple of 6. Which again So our 6 is our 2 and our 3, but we don't know about our 5. So together, our two statements are telling us, statement 1 says x is a multiple of 5, statement 2 says x is a multiple of 6. That means between them, we have our 2 and our 3. That gives us the 6. Then we also have the 5 from over here. So it's a multiple of 5 and 6. It must be a multiple of 30. So together, these guys are efficient. So let's do another one similar to this, but a little bit more complicated.